All right, so now that you guys know the legend of Sokotoa, you can share it with all your friends. You can. It's a good campfire story. Okay.
What day is it?
But you try to remember when we're dealing with sine, cosine, tangent. We remember the little. I've been told today that it's not a jingle by both my trig classes. It's not a jingle Sokotoa. It's more of a chant. So as you walk through the halls, you can be chanting Sokotoa, Sokotoa, Sokotoa. You know, people really look at you weird. So, but yeah, Sokotoa. And spelling matters here, right? Sokotoa.
Oh yeah.
Sorry, Hannah, you can sharpen your pencil. Do you want to sharpen it? You need to. You can. All right.
So what about spelling here?
Well, I was actually just going to keep rambling to see how long Hannah would stand there. She gave up really fast, so I had to, no. So it really does matter. Sine, so this is sine. And we actually spell sine as S-I-N-E. Your calculator abbreviates it as sin. There's nothing wrong with sine, so okay. A sine is equal to opposite over hypotenuse. Okay, so when we're dealing with this, we're dealing with a right triangle. This only works in right triangles. So notice in your learning goal it says calculating tangents of acute angles in right triangles. So when you're looking at a right triangle and you have an angle, say we call it angle X here. Next year we'll call it angle theta. But X, okay? If we're dealing with angle X, the sine of X is equal to the opposite side, so the side opposite of X, the one it doesn't touch, if you want to think of it that way, or if you trace this angle, it's the one at the end of the legs of that angle. This is the opposite side. The opposite side varies, as does the adjacent side. The adjacent side is the side that touches the angle and is not the hypotenuse. The hypotenuse, as we'll call it, the hypotenuse is your longest side. It is the side opposite the right angle. It's right across from it. Okay? So if we're cruising in on this, now that you guys have the learning goals down, we're zooming in on this. The sine of X is equal to opposite over hypotenuse. The cosine, which we abbreviate as cos, C-O-S, not Bill, no relation, okay, is equal to adjacent, the adjacent side, over the hypotenuse. And then the tangent, which we are studying today, is equal to the opposite over the adjacent. Oops. Now I have had some very artistic students and some creative ones, more so than I, that have listed this in many different ways. Probably one of the best ways I've seen it is like this. So they write so like that, ka like that, and toa like this. Okay, it's up to you. You write so, ka, toa. I've seen some just write it vertically. They go, oops, just write it as so, ka, toa. And so they just have it set like that. So they write your sine, your cosine, and your tangent. I don't care how you write it, I just care that you remember it. It's probably one of the things, like if you went back to your parents and said, hey, we studied trig functions today, sine, cosine, tangent. A lot of them would recognize Sokotoa. They would recognize, even though if they don't remember what it means, many of them would recognize it. They may not know the legend, you might have to tell them. But, okay. Very good. Vogel does, but I don't know that he tells it. I know. It's sad. I
He
get
said he
it.
might not tell us this.
Okay, so, Katoa, here we go. It's not ever going to get old. So what we're going to do here is, on the example side, this number 1. On number 1, we're going to go through, write the tangent ratios for each pair of angles. We're just focusing on tangent today. And this is really, I mean, after today, you'll be like, man, I get it. There's a lot in trig. Like, I mean, we're just really, really scratching the surface, the very, very basics of it. And that's all we'll get into this year. Okay? Tangent actually means something else, and you'll deal with tangents when we get to chapter 12, and that'll make a little more sense to you on what an actual tangent is. But for now, we're going to try to figure out the ratio. What does the word ratio mean?
Proportion.
It goes with proportion. It is a comparison. It's a comparison which we write it usually in fraction form. Okay, so a ratio is just a fraction. Write the tangent fraction, so this, opposite over adjacent, for each pair of angles, x and y. So at angle x, I want you to trace angle x. I always tell students to trace it, and there's a reason, because usually at some point they start forgetting or struggling with this. So there's angle x. There is a side you did not touch. That is your opposite side for angle x. You can go ahead, Jordan. Thank you. Okay, so in relation to angle x, that is the side opposite of x. When I traced x, I did not touch that side. I didn't trace it at all. Okay, so the tangent of x is equal to, this is opposite. What's adjacent?
The one that touches it.
Go for it.
The one that's like next to it.
The one that's next, this one?
Connects
Not
to
the
right
hypotenuse.
angle and
Good.
angle.
Good. It's the one that's not, or the one that's next to it, and it's not the hypotenuse. So the tangent of x is opposite, or 3 over 3, which in this case is 1. All right? Everyone do tan y, please.
Do you want us?
That's really bad focus. I don't know if that was much help. Okay, what's the tangent of y? Lee? It's also 1, right? But in this case, this side is not, it's the opposite of x, but it's the, when we trace it, for y, it's the adjacent of y. And this one is the opposite of y. Okay, notice we trace angle y, we don't hit that side. So that would be also 3 over 3, in this case 1. Questions? That's our final answer right now. Yeah, we're just writing the ratio. That's, in fact, all you had to do is write 3 over 3 or 1 on that. Okay? Good.
Do you have to move radicals up for this?
Yes, we will move right. Well, when we're writing the ratio, I don't think we will.
Okay.
Okay, if we're just writing the ratio. That's a good question. Gracie asked, do you have to move the radicals up? In other words, do you have to rationalize them, move them out of the denominator? And the answer is, if we're just writing the ratios or calculating, the answer, you don't have to do that. Now, if that's your final answer, if we're leaving it in radical form for a final answer, then you would have to. Okay? Any other questions? All right, once you got, oh, hey, a comment. Come on. This one I'm not too fond of. However, I leave it in there just for you guys. I'll let you read it. I don't laugh at it. I don't appreciate it that much, quite honestly. Stupid cow. All right. Oh, who wasn't done? Sorry. Oh, you don't need to see it, Lou. I don't care. You need a love map. Yeah. All right. Very funny. Example side, number 7. Find the value of x, round your answer to the nearest tenth. So the first thing we need to do is we need to figure out usually you're given an angle and a side, and you're going to figure out what side you need to find. So if I'm given this angle, angle 55, if I trace the angle, everyone always trace the angle, because then that tells you which two sides you're dealing with. Okay? So when I have my 55, I'm dealing with what two sides in relation to that? 4 and x. 4 is called our, it's adjacent to that. And x is called our opposite. Now, today we're dealing with tangents, so it's pretty easy, right? We're probably always going to be the tangent function. However, after we do 11.2, which is sine and cosine, then we move to 11.3, which is, or we move to a review, which is all of them mixed up. And on your quiz, they're all going to be mixed up. So you have to determine which one you're using based upon what they give you and what you're looking for. Okay? So in this case, let's see if we can set it up. So that means the tangent, since we've determined it's opposite and adjacent, which in SOHCAHTOA, that's our tangent. Okay? We've got the tangent of our angle is equal to the opposite side, which is x, over the adjacent side, which is 4. So now we have an equation we can solve. Now for some students, it's very tough when you look at tangent 55 to realize that that is a value. It represents a number, like the square root of 5. Okay, or the root of 7, or any square roots. Those all represent numbers. If you punch into your everyone in your calculator right now, type in tan 55.
Can
I borrow your calculator, Maddie?
I thought -45.
Okay, now some of you are going to get different answers depending upon what your calculator's actually, what mode they're in. Now this is Maddie's calculator. All right. And if we go to mode, if you have a graphing, you want to be in degrees. If you have a scientific calculator, so by the way, if radians is highlighted, and if you borrow my calculators, Trig right now is doing this, and they're measuring in radians. You need to be measuring in degrees. So if you have to change that, go over here and select degree and hit enter. If you have a scientific calculator, up on the top it'll say rad, that's bad. For you want to be in deg, D-E-G, which means degrees. If you don't know how to change that, ask me. JJ, question? Did you figure out how to do it?
What if there's like a D highlighted?
That means if it's a little D highlighted on your scientific, that means you're in degrees. Okay, so once again, you click on mode here. All right, so notice Maddie she put in tangent 55 is 1.4. That's the actual numeric value. So if I said, hey, what's tangent 55 worth? You would say, well, it's worth like $1.42, $1.42. $1.43 if we round up, okay? Okay, it has a value. This is saying approximately 1.43 is equal to x over 4. Now, if I gave you that, if I said 1.43 is equal to x over 4, what would you do to solve that? Thank you.
Multiply by 4.
You multiply both sides by 4. Okay? You just get rid of that. Some people would maybe even cross multiply, right? You have a proportion here. Okay? Either way. So I'm not going to say 1.43. We're going to actually use the word tangent. So on your calculator, what you need to do is if you cross multiply or multiply both sides by 4, that gives you tan 55 times 4 equals x. Everyone calculate what 4 tan 55 is. I think we'll round to the nearest tenth today. 5.71, which is 5.7 is x. That's a length.
Mr. McCoy?
Yeah.
Why didn't they get that?
Get that? Let's see. Can I use it as an example? Okay. So here we want to put the 4 on the outside.
Okay.
So we'll go 4 tan 55.
Okay.
Get in the habit of closing parentheses, even though it wouldn't matter there. But, good job. Thank you. Okay, everyone try number 8. I'll be walking around helping out. Ask me if you have questions. Okay. So the question was asked, what does tangent represent? For those of you who really want to know, this is what you'll be studying at this time, actually right around this time next year. This is called the unit circle. You're dealing with right triangles. Here's cosine, here's sine. This length right here is tangent. This piece. These are the other 3 trig functions. Cosecant, secant, and cotangent. It represents a length of a line that is tangent to the unit circle that hits the x and y axis. Okay, so really for your background, that really doesn't mean much of anything to you. But that's what it represents. It also represents, if you want to think of it this way, tangent always represents sine divided by cosine. If you divide the sine, like on this last problem we did, if you divided the sine of 55 by the cosine of 55, you would get tangent 55. Okay? All right, we're on number 8. Give it a go.
Yeah, that means.
Wait, how should I do that?
Which one's the one where you have to use
Don't you have to have that?
tan negative 1?
Ah, that'll be coming up soon.
When, like,
I
is
got
that
one.
one?
Figure it out. So I didn't figure it out. I got 18.1. 5.31.
What? I got about 14.
Okay, how many got that for number 8? You guys are flying through this stuff.
Yeah.
Okay, so I'm just labeling opposite with an O, adjacent with an A. Cross multiply, we get 20 tan 35. And the reason why I keep saying cross multiply is because it's not always as easy as that. And when we get to law signs, law cosines, you'll actually use ratio or proportions more. So I keep going with the cross multiply bit. But what does this give us?
About
14, like 14.001.
Okay, so about 14.0. So if it says round to the nearest tenth and it's 0.0, put the 0.0 on there. Okay? Any questions? How many have done number 9? Okay. Question, Bennett?
Do we have to label the feet and centimeters and stuff?
It's a good idea. Did I miss that on the last one? Yeah, 5.7 centimeters on the first one, 14.0 feet. Yeah, I wouldn't mark it down right now, but it's always a good habit. Okay, how many have finished 9? Okay, go ahead and try 9. If you finish number 9, you can move on to, or kind of finish up that section. We'll be going on to,
I'm not sure if we got it right.
okay, we're going to, number 9,
Yeah.
we're going to go through it right now.
Okay.
Hey guys, I'm tracing this. Please make sure you're staying. I know that there's a variety of levels in here. Some of you have done this before at Math Academy or in POE. Some of you haven't done it ever. So please stay with me, and if the person next to you needs help, like talk to them, help them out. So the reason I trace, the only reason I'm getting you in the habit of tracing is so that you know which of the 3 trig functions you're dealing with. So when I trace that in relation to our trig functions, this is SOHCAHTOA. That's our opposite side, and the other one they give us is our adjacent side. So opposite and adjacent is tangent. So the tangent of our angle. Okay, that was the other thing. We always go whatever the trig function is of our angle. So in this case, the angle 62 is equal to opposite over adjacent, or 10 over x. Okay, now this one's a bit different. X is on the bottom. So when we cross multiply here, we get x tangent 62. The reason why we keep tangent 62 as...
Almost off the screen.
Yeah, thank you. The reason we keep tangent 62 as tangent 62 is because if we don't, it's a big long decimal. So x tan 62 equals 10. So now to get
Divided by 10.
x by itself, we have to divide 10 by
Tan 60.
tan 62. So we can divide each side by tan 62. Those cancel. X is, what is 10 divided by tan 62? What's that?
5.3.
5.3 yards. Thank you. So who's right on it? Eli, question?
Can you just find the other angle?
You could, but then you're using a different, then you're flipping it, right? Eli's question is, couldn't you just say, rather than, I mean, we know that if this is 62, then this is 28. And so I could say the tangent of 28 is x over 10. That's true. You could do that. Okay? All right. Everyone rate themselves 1 to 5 right now. Okay. So we have... Hey, let's go on to this next piece real quick. We're going to find the angle measure. Inverse tangent, tan negative 1, also known as arctangent. Okay, we use the inverse tangent to calculate angles. So we're looking at the mixed side now. This is number 13. Okay. We use the inverse tangent to calculate angles. We use tangent to calculate sides. So if you look at your calculator, right above the sine, cosine, tangent buttons, there's a sine negative 1, cosine negative 1, tan negative 1. Okay. Please memorize this. This is for angles. The regular tangent key is for sides. So you have to know which ones you're calculating. So in number 13 it says find the value of x, round your answer to the nearest degree. Well, when they tell you to round to the nearest degree, that's a good hint that you're finding angles. And then when you look at the problem for number 13, the variable is your angle. So we still trace that angle. We still label our sides. However, when we write our tangent function this time, our angle is our variable. Okay, so usually we do inverse operations to get rid of things. In this case, to get x out of this, it's locked. It's like right now it's locked into this function. You can't just separate it. You can't divide by tan. Tan without a number by it means nothing at all. Okay, it's like having a square root. It's like me saying, hey, what's the answer to that?
Square root?
You'd be like, I don't know. It's like square root. What does that mean? It doesn't mean anything if you don't have anything in it. So tan doesn't mean anything without something with it. So to get tan out of here, so we just have x, we take the inverse tangent of the other side. So when we move tangent over to this side, you get inverse tangent. You're taking the inverse tangent of 4 over 5. Okay, so the inverse tangent of 4/5 38.66 67, which we're going to the nearest degree, right? So that would be,
Yeah.
it'd be 39, nearest degree, right? That means round to the nearest whole degree. So it goes up to 39. Okay, try number 14. I'll be walking around. Keep asking questions. Okay, how many made it that far? Tan of x degrees equal to 9 over 3. You could reduce it if you wanted to. Won't matter either way. I'm not going to worry about it. I'm going to move this over. We get x degrees is equal to the inverse tangent. When we move it over, it becomes inverse of 9 over 3. And so x equals?
About 27.
I wrote 72. You're on the wrong one.
Oh, sorry.
72 degrees?
Oops.
How many got that?
Yeah.
All right. Questions? Okay. Last piece. I want you to take a look at number 13 and 14 on the example side. Actually, there's one little piece after this, but it's really quick. So, find the measure of the acute angle that each line makes with a horizontal line. Round your answer to the nearest 10. That just seems like way confusing.
Yeah.
Okay, so what you have to think of, this type of line, that's a linear equation, right?
Yeah.
This type of line, okay? It crosses at -1. You do not have to write this every time. I'm just showing you what they're asking. Okay, so we're at -1. we end up,
Your slope is
our slope is 2, so I'm not even going to worry. 1, 2, and over 1. I'll find one other point. We'll draw our line. Don't be jealous of my right triangle ruler. Okay? There it is. Now that didn't do anything. It says, find the measure of the acute angle, less than 90, that each line makes with a horizontal line. Now, let's pretend for a minute that there is a horizontal line going through this right here, right at the y-intercept. Everyone with me? And then if I wanted to make a right triangle out of this, I'll just drop an altitude from this other point. How many see the acute angle that it made with the horizontal line?
Yes.
If you can't see it, let me give you a hint. That's your hint. All right? It made an acute angle with the horizontal line. All right? Everyone with me?
Yes.
Okay. So, I'm trying to find this angle. So, do I know this length?
1.
I went over 1. That was my slope, right? This was 1. How much did I go up?
2.
2. This is the adjacent. This is the opposite. So really, man, that looks like enormous up there on the screen. It's awesome. You can't see adjacent. Hold on. Woohoo. Okay, let me zoom out now. I know. Okay, really, if I'm setting this up, I'm trying to find the tangent of my angle, which is right here. Let's call that angle A for being cool. Tangent of A is equal to what over what?
2 over 1.
2 over 1. Where could I have got that 2 over 1 than drawing the picture?
Up there. In the equation.
It's our slope. Right? So the quicker way is to just take the slope. Take the tangent of the slope. Or the tangent of your angle is equal to your slope here. Okay?
So how would you plug that in?
Well, that's just A is equal to, we move that over, right? The inverse tangent, 2 over 1. Lee?
How do we know not to use the other angle, the other angle?
It's a good question. Let's figure this answer and then I'll answer it. What's this answer?
62.4.
62.4 degrees. We're rounding the nearest. It says nearest tenth this time, so we got a nearest tenth.
63.4.
63.4. Okay, I thought you were going 63. Thank you. Okay, Lee's question's a good one. How do we know we're not dealing with this angle? The reason I know that is because it's not the angle that's connected with the horizontal. It's the angle that's connected to the vertical. You see what I mean? It's formed, this one's formed with the horizontal. Okay, so you guys, you don't have to draw that picture every time, right? If I'm dealing with number 14,
Tan 3 over 4.
I want everyone to write down what your formula is going to be, or your equation, your tangent equation is going to be for number 14. Get about 15 seconds. Okay, show your neighbor now.
So long.
Okay, if I'm sticking with tangent of angle A, it's equal to what over what?
3 over 4.
3 over 4. How many got 3 over 4? You're good. Yeah, it's just your slope. Your tangent of your angle is equal to your slope. Okay, and then you solve from there. Questions?
So, I know this may seem stupid right now, but
No?
when you have, like, for example, 75.96, do you want us to leave that 75.9, or do you want us to round up to 70?
On this one?
17, yeah.
On,
Do you end up with,
on 17?
yeah,
Is it a problem? Is it, yeah, if it says 79.96 for number 17, it says 79.96. 6 makes the 9 become a
Yeah, but
0, and the 0 makes that, yes.
Do you want it as the?
Yep. You round up.
Okay.
Okay, last thing. Tell your neighbor what you have to do on this set. We're not going to work through all these. Don't just reread the directions to them. Next side. Such horrible focus.
Sounds like we just did. It's like like
12
and 46. Yeah.
Okay, time's up. Here's your hint. Put an X here. Now, how many were going to do the right thing?
Me.
What do you do there?
Divide.
How do we solve this?
12 divided by.
No.
Wait.
12 times.
Good. Cross multiply. Just treat it just like you do the other problems. Okay? Equals X. And solve for X. 12.4.
And then the other one would be tan negative.
All right. Yep. And then this one's an inverse tangent one, right? Because X is in your in your degree now. All right. That's all we got. Your assignment is the mixed side.
I did most. I did all of the